Displacement reactions. There are two types of displacement reactions we can say. One is the metal displacement reaction. Other one will be the double displacement reaction, which is also known as double decomposition reaction. So first we will try to discuss about the metal displacement reaction. What is it? Consider this example. Take a small container like this, and in which just fill certain amount of copper sulfate solution. Okay, in the copper sulfate solution, we are going to keep a iron nail. Iron nail can be kept. Okay, if you do so, after some time, this will be the change. The solution is becoming green. Originally, the blue color copper sulfate is taken, in which iron nail is kept. After some time, this is changed into FeSO4, ferrous sulfate. The color of the solution is turning into green. And what about this nail? On the surface of the iron nail, yes, we can see the deposition of copper. The copper is deposited on the upper surface of nail. How it is possible and why? This is the reason behind that. If you take Fe and copper sulfate, it is a solid and this one is aqueous. Here the reactivity of copper and iron are compared. This is more reactive, the iron, so that it can displace the lesser reactive copper from the copper sulfate. Due to this displacement, we will be having the following substance: ferrous sulfate, aqueous, and this copper is being released from the copper sulfate. Due to this, the originally taken blue color solution is changed into green due to the formation of ferrous sulfate. And the copper is released from the copper sulfate. Thus released copper is deposited on the surface of iron nail. That's the reason why we can see the dark red color deposition on the upper surface of this nail. It's an example of metal displacement reaction, and this is the equation which is applicable for that. Is it clear? Very simple. Yes, if it is the displacement reaction, metal displacement, consider a metal which is going to react with Bc, another substance, having the metal part and non-metal part. Suppose A is more reactive than the B, the reactivity differs like this. Here, which is more reactive metal? A is more reactive. So that it can displace the lesser reactive B from the Bc. Yes, and what's the expected substance? AC and B is being displaced. It's a common pattern for the displacement reaction, metal displacement reaction. We can have some more examples for this particular category. Zinc on treatment with the copper. What is happening? If you compare the reactivity of Zn and copper, Zn is more reactive. We should know that more reactive Zn can displace lesser reactive copper from the copper sulfate. It is a solid and this is a solution AQ. After the displacement, the products formed are ZnSO4 aqueous, and this is the substance being released out. Copper is released from the copper sulfate. So it is another example of metal displacement reaction. We can take the lead, another example, Pb when it is in contact with the cupric chloride. This is copper 2 sulfate, also known as cupric sulfate, blue in color. This is cupric chloride, also known as copper 2 chloride, the solution. If you compare the reactivity of lead and copper, most probably lead is more reactive than the copper. So the lead can displace copper from the copper chloride, and the product expected is PbCl2. Copper is being released from the substance and lead chloride is obtained due to the displacement. And these equations are self-balanced, you need not balance them. So very simple, the metal displacement in which the most reactive metal can displace lesser reactive metal in a particular metallic salt solution. After the displacement, we can have the products as follows. These are the examples. Zn is displacing copper from the copper sulfate. Lead is displacing copper from the copper chloride. And so many number of examples can be given. This is more than enough. Is it clear? Double displacement reaction. What will be the general format? Consider there are two substances A, B, C, D. Here the metal part is A, and in this case the C is the metal part. In the double displacement reaction, A is going to displace this C. Thus displaced C can combine with the B. So what are the products expected? We can have A is occupying this particular position so that we can have one product as AD. The C is a metal part that can combine with this non-metallic part so that the other product is BC. And hence this reaction is a double displacement reaction, also known as double decomposition, because A is decomposed to form AB, C is decomposed to form CD. The metal can combine with non-metal D, AD. The metal C is combining with non-metal B to form BC. Hence it is a double displacement, also known as double decomposition reaction. You can have so many number of examples. One of the examples for this particular case can take sodium sulfate, Na2SO4 solution on treatment with barium chloride solution. Take a test tube in which certain amount of sodium sulfate is taken, and we are going to add barium chloride into that. After the addition of barium chloride, after some time, we can see the deposition of white color precipitate. And which is responsible for this white color precipitate? This is a responsible substance. Here the sodium is going to combine with the chlorine, and barium is going to combine with this sulfate. So one of the product is barium sulfate, BaSO4, and other product will be sodium chloride, NaCl. The equation can be balanced like this. The barium sulfate might be in the form of solid. So to indicate the precipitate, we can have a downward arrow. Otherwise, we can put yes, solid. It is white in color. So which is responsible for this white precipitate? Barium sulfate. And the sodium chloride solution is obtained there. I repeat, both the substances are decomposed. Sodium sulfate, after decomposition, you can have sodium and sulfate. Barium chloride, on the decomposition, you can have barium and then chlorine. Barium is a metal that combined with sulfate, non-metal. And sodium is the metallic part, combines with the non-metallic part, chlorine. or chloride ion to form sodium chloride. It's an example. And otherwise we can take the another example. Take little amount of lead salt, namely lead sulfate, on treatment with potassium iodide, Ki. What is happening? It is a solid substance, it is an aqueous, and this is also an aqueous. The potassium is going to combine with SO4 and lead is going to combine with iodide. And the products formed are PbI2, and we can have the other product K2SO4. And for balancing we can write 2 times. The lead iodide might be in the form of solid and this one is aqueous. The lead iodide obtained may have a color, specifically yellow color. This is possible during the double displacement reaction, also known as double decomposition reaction. It is getting decomposed like this and this is also decomposed. Pb combines with iodide, potassium combines with sulfate. So these are the few examples of double displacement reactions. Is it clear?